Okay, so here we have our project. So here is call module with SIM 800L and a SIM card inserted inside it. So this call module is connected to two other ESP32s over a serial connection. So here you can see a simple circuit that's connecting two ESP32 dev modules with one ESP32TT go call module. So now an antenna is also connected to the call module, so in order to get a good signal reception. So here we go with the firmware. So I have made 4 different folders that I am going to provide you. So first one is the circuit folder. It contains a pin out diagram and a circuit diagram with details written on the left side. That's how you can connect your ESP32 dev modules with your call module in order to get UART connection. Then I have ESP32A or first ESP32 dev kit firmware. You can change anything inside it, but you have to keep the baud rate 19200, and you can change the string to anything in it. So I have just put UART ESP32-1 in order to make sure that it's sending the same data to the call module. So you can change serial the println command to anything else, and please don't change \r. There are like 6 \r's. They are here to make sure that the data is sent correctly. Then we have ESP32-2. So this firmware is for ESP32 dev kit, which is second one. It's exactly the same as the first firmware, and the only changes here is the character 2 edit. So I have replaced the 1 with the 2, so to speak, to check that the both of the ESP32s are sending different data over the UART. And here goes the main firmware. So it's also an Arduino code that you will be uploading in your call module. So here are the major points that you need to keep in mind before uploading this. So when you scroll it down, you see there is a line with a character defined name as APN. So you'll have to change it to your APN. So whatever SIM card you are using, you can find its APN details on the internet. And most of the SIM cards don't use a username and password, but few of them do. So if your APN details also has a username and password, you can put those here. In my case, I don't have username and password. I just need to put this string, which is my APN detail. So other than that, here we have a server. So whenever you are going to make HTTP request, you will have to put a proper server here. So it's a test server, and it works usually without any errors. So I'm using a test server here, and here down below is a resource. So you will be like sending data over the HTTP with some resource. Like in my case, in our case, what I have done is I am collecting the UART data from both ESP32s, and then joining them separated by comma and sending it to this server using this string literal. So that's very simple. You will just change it to your server, and you can keep it as it is. But here are the things that you need to change. Down below we have port defined, which is port 80, and that's the port for HTTP get and post request. But if you have like HTTPS based thing, you can change that too. So let's test it. So I open the serial monitor. You have to select 115200, and let me restart it. So it's trying to connect to the server. First it looks for the network based on the SIM card that you are using. So here it's trying to connect to the SIM card network. It's connected, and it's trying to get the data from two ESP32s, and yeah, it got the data over the UART. Let me show you how it's done. So here we are, scrolling up a little more. So yeah, so here what it does is it gets the data from ESP32 1 and then ESP32 2. So it collects the data from both of the ESP32s, and then it prints the data. So here's the from ESP32 1, the data sent is UART ESP32 2, and the data sent from ESP32 2 dev kit is UART ESP32 1. You can change that in the respective firmwares. So one important thing to note is you will have to connect both ESP32s in order to get this firmware work, because it looks for data being sent from both ESP32s, and if it doesn't find any data from any of the ESP32s, which may be because your ESP32 is not connected, one of the ESP32s is not connected, it will not work. So you have to connect both ESP32s, and both ESP32s should be using a println command with some with some sort of string in it. So it found the data, and data is valid. It has a length greater than 0 in both cases. So it is now trying to connect to the server. Once done, so what it wasn't connected, then it again tried to connect to the server, and yeah, it's connected over the port 82. It's performing the HTTP request and done. After that, we go down. So here what it does after making an HTTP request is close the connection in order to save the data used by SIM card. And after that, in order to save the power being used, it hibernates ESP32 and the SIM module for a few seconds, so to speak, and then again it tries to connect and do the same thing. So that's how everything is working. So the test, I have shown you a test demo which is working very fine on my end. You can do the same. Please make sure to change the APN details and the web server details and the resource if you want to change it to, and the port as well. So that's how it's work. One more thing, the last thing is, if you want to make sure that your call module goes to deep sleep to save the power for more time, you can change this number. So for now it sleeps everything for 2 seconds. You can increase it to like 5, 60 or any number of seconds to save the power if you are using the battery. And if the data packet is greater, you can change this 1024 number to anything. It's in kilobytes. So that's how everything is working.